Hi, my name is Gary Waldo. I'm a product planner here at Tektronix, and today I'm very excited to tell you about a cool new feature on our 5 and 6 series scopes called Spectrum View. Normally, when you think about frequency domain analysis on an oscilloscope, you think about FFTs. However, FFTs are notoriously difficult to use for two primary reasons. First, the setup is very difficult as you need to know how sample rate, record length, time per div, all affect the frequency domain display. Next, those key scope acquisition parameters, sample rate, record length, time per div, all affect both displays, the time domain display and the frequency domain display. What this means is that most of the time you can either optimize your view of the frequency domain at the expense of the time domain view, or you can get an optimal time domain view, but your frequency domain view is messed up. Today, we're going to take a look at a spread spectrum clock that modulates from 97 megahertz to 100 megahertz, and we'll take a look at it using both traditional FFT and spectrum view to see how they are different. The first thing I'm going to do is set up a traditional FFT display. I'll do that by adding a math waveform, setting it to FFT, and you see up here a spectrum, but I'm not really interested in the entire spectrum. I'm really just interested in the frequency range of the spread spectrum clock. So I'm going to change my view from to 95 megahertz to 102 megahertz. And this is our resulting FFT display. Notice that I just get a flat line across the top. This gets to the point that I was making above understanding the sample rate, record length, and time per div settings of the oscilloscope. Resolution in my frequency domain display depends on the amount of time I capture in the time domain display. So to increase my resolution here, I need to capture more time here. So let's go ahead and do that. As I go to slower and slower sweep speeds, notice that I get better resolution in my FFT view, to the point where when I get to 10 microseconds per division, I can see the characteristics of my spread spectrum clock. But to achieve this setup with a regular FFT, I had to understand the implications of sample rate, record length, and time per div settings on the FFT. Let's look at this using Spectrum View now. Spectrum View is a new feature that allows any flex channel on a 5 or 6 series to be configured as an analog channel, digital channels, or a spectral view of the analog input. In this case, we're only going to look at one channel. So I select channel 1, go to Spectrum View, and turn it on. The first thing I'm going to do is drag this view such that I can see both of my frequency domain views side by side for easy comparison. Couple of things to notice immediately. First, automatic peak markers indicate the frequency and amplitude of the highest magnitude peaks in the Spectrum View display. Next, I get a spectrum badge down here that indicates my center frequency, span, and resolution bandwidth of the Spectrum View display. So I'm going to double tap that, set my center frequency to 98.5 megahertz, and set my span to 7 megahertz. Notice now that both views are showing my spread spectrum clock. So at first blush, you may think, well, what's the big deal about Spectrum View? So first major difference, this view was much easier to set up than this view. Remember here I had to understand implications of my time domain settings. Here, all I had to enter was center frequency and span. But more importantly than that is this view is still tied to my time domain controls, whereas this view is not. So why is that important? Well, let's say that I wanted to look at a few cycles of my spread spectrum clock. I do that by changing my horizontal scale here. So I'm going to scale in until I see just a few cycles of my clock. Notice what happened to my FFT view. It's back to showing a flat line across the top because I don't have enough resolution because of my time per div setting. Notice Spectrum View. It's still rock solid, showing the exact same view that it was before. So that's with faster time per div settings. where you will oftentimes find that your FFT view is useless. So now what happens if we go to slower time per diff settings? For example, on channel 2, I'm looking at an RS-232 control signal. So if I go to where I can see several cycles of the RS-232 signal, and again observe my frequency domain displays, notice that spectrum view is again rock solid, still showing the exact same information. Yet my FFT view is now not only not showing a flat line, it's not showing anything. The reason why, if we look down here to our acquisition settings, we're acquiring at 62.5 megasamples per second, which is not enough to capture the Nyquist information on a 100 megahertz spread spectrum clock. So in summary, spectrum view addresses the two key shortcomings of traditional FFTs in terms of frequency domain analysis on an oscilloscope. It's exceptionally easy to set up, and you get independent controls for your time domain view and your frequency domain view. So you maintain a useful frequency domain view at all times.